Hi everyone! In this video, I'm going to talk about loops, while construct, for construct, and break, which is a way to exit a loop. So by now, we know how to add branching in our program and to include some conditions or tests. Let's take a look at this example. Let's say we have this problem. Ask the user, "Are you okay?" until he or she is okay. If the user answers yes, tell the user, "Wow, I'm happy for you." Otherwise, ask the user again, "Are you okay?" So let's think about this problem and let's think about how to solve this one. So since by now all we know um, is the if-else construct. So let's try to solve this one using branching or the if-else construct. We can have this algorithmic solution. So ask first. We ask the user, "Are you okay?" and put the response in a variable ans. If ans is equal to yes, print to user, "Wow, I'm happy for you." Else, we ask again the question, "Are you okay?" and put response in a variable ans. If ans is equal to yes, print to user, "Wow, I'm happy for you." Else, if it's false, if it's not yes, ask user, "Are you okay?" and put response in a variable ans. If ans is equal to yes, print to user, "Wow, I'm happy for you." Else, ask user, "Are you okay?" and put response in a variable ans. And so on. So, did you notice something? Um, we, the program just repeatedly asks or repeatedly executes this same command or this same expression. And then the question is also the same. And here, we ask the question, "Are you okay?" Let's say if the user answers yes on the second question, all right, this program is good. If the user answers yes on the third question, yes, it's okay. But then what if the user answers, let's say, no 10 times? Okay, and then on the 11th time, that's the only time he would want to say yes. And this algorithm will not work anymore. Okay, so well, sure, we can make 10 if else or even 100, but then the problem is we really don't know how many times the user will say no. Okay, so it may be infinite. Okay, there's no definite answer with a number of times that he would answer no. Okay, so if we want to take a look at it visually, we can translate it into a flowchart. So if we write a flowchart, here is the flowchart equivalent of that algorithm that I wrote or I created. So the first one is an input ask, "Are you okay?" And then there is a test or a condition. Is ans equal to yes? If the answer is true, we output the program the program outputs print wow. Otherwise, if it's false, if the answer to this condition or test is false, we ask again this same question and check again, is ans equal to yes? If it's true, we print wow. Otherwise, if it's false, we ask again the same thing. If you'll notice, this part, this steps that I copy and paste next to it next to the flowchart. I add to the flowchart. Um, it's just the same steps. For example, here, you ask again. If the answer is false, ask again, are you okay? And check if answer is equal to yes. And so on. Um, when do we stop, or when should we stop? Actually, we don't know, because we don't know what's inside the mind of the user. Okay, so using this type of problem will not be solved by simply using the if else construct. That's why now, for this in this video, I'm going to introduce to you the looping construct, or loops. Okay, so for example, here we have, are you okay? Ask, are you okay? The same thing. And then check, is answer equal to yes? If true, print wow. If false, ask the question again, are you okay? And then what should happen next? Loop allows us to go back to a point where we want to execute or do the steps again. So here you could imagine that this is the loop, and this two are the steps that we want to execute repeatedly. Okay, so when will this two be repeated? When the answer is not yes, and the loop will only stop if the user answers yes. Okay, so instead of the previous instead of this, which is tedious, also not the correct solution, this one is the simpler and correct solution. So while loop is a construct of is a looping construct. So while, here is the algorithm of while. So while we initiate sentry. Sentry is again the variable that will control the loop. So initiate sentry with initialization code, then continue loop as long as condition. So condition contains the sentry. Okay, so as long as condition is true, and then inside loop, change sentry with change code. Okay, this is the general algorithm of the while loop. Okay, we have to take note that there is a sentry, and this sentry, most of the time, or if not all the time, is part of the test or the condition. And make sure, that's why you have to make sure that the sentry has an initial value before we even test it here in the condition. Also, we have to make sure that the sentry there is a line of code inside the loop, in the code body, in the code block, that changes the sentry, or changes the value of the sentry. Okay, so that at some point the condition would become false, and then the loop will end. Okay, so this is very important because we don't want our loop to run infinitely. So at some point we want our program to stop and not to be stuck inside the loop. Okay, so in Python, the while loop syntax is this one. So we have while, and then the condition, colon, and expression. So this set of expressions or lines of codes is a code block. So here, condition evaluates to a Boolean. So it's either true or false. And if condition is true, do all the steps inside the while code block. Check the condition again and repeat until the condition is false. So this code block will be executed until this condition becomes false. So if we're going to translate our solution, which I showed earlier, we can write it in this manner in Python. So this is the code that equates, or that is equivalent to the flow chart I showed previously. So here, ans gets input, are you okay? And then while ans is not equal to yes, we continuously ask for user input. If the answer is yes, that's the time the program exits from this while loop and then prints this, wow, I'm happy for you. So this way, even if the user answers no 100 times, 1,000 times, this is still a solution to the problem. Let's take a look at another example. Let's say we have this problem, display all the digits in the decimal number system. And then the algorithm for this one is first create an integer variable n with initial value 0. And the next step is repeat the following while n is less than 10. And then the following, here are the two steps inside this loop. So the first step here inside the loop is display n, add or show n or print n, and then next is add 1 to n and put it as new value for n. When we translate this to a Python code, this is the equivalent code to this algorithm. Okay, so here is the code. We have n, we have a sentry, and we have an initial value for the sentry, and then we have a condition that contains the sentry, and then we have a command here to print, and then a way to change the sentry. Okay, so this is the code for this problem. Well, this code can be converted into a for loop also. So for loop is another looping construct, and I will show you later that for that type of problem, the for loop is simpler to code. So the for loop, also a looping construct, is of course very similar with while, with just a very minor variations to it. So the algorithm for is begin with sentry at start. Start is the value of sentry at the beginning, and add step, which is step is the integer to add to sentry at each pass into the loop. So add step to sentry on each pass until sentry is larger than or equal to stop, and stop is the integer value of sentry at n. So in Python, the syntax of for loop is this one. We have for, the variable, in range, and then inside parentheses, we have start, comma, stop, comma, step, colon, and then the code block. So this means, to translate this means each time through the loop, variable takes a value. The first time, variable starts at the smallest value, which is the start. The next time, variable gets the pre-value plus step. So it means The step is the increment. So the value that you add to start. And then you loop until the value is stop minus 1. So default values are, well, the start and the step are optional. And if start and step are not there, so let's say there is only one value here. So the default value for start is 0, and the default value for step is 1. So for example, so here are some examples of range. So here in the first one, for n, in range 10, print n. This is the equivalent code in for construct of the previous problem, of the previous while problem I showed you. And then here on the next example, this is a second example, by the way. So here, my sum gets 0, and then for I in range, we have only two values, 6 and 10. Here, this means this 6 is the start and 10 is the stop. So this example gets the sum from 6. It will run until 6, 7, 8, 9, not including 10. And then on the third example, we have my sum gets 0. And then for I in range 5, which is the smallest value, 11, that's the stop, and the increment is 2, or the step is 2. So this one gets the sum of 5. You add 2 to 5, so becomes 7. Then add 2 to 7 plus 9. Add 2 to 9 plus 11. And 11 is not included, so it will just be 5 plus 7 plus 9. So let's take a look at the for and while side by side. So here is the for printing what do you call this, the digits from 0 to 9. And then on the right hand side is the while. Using while, we also print from 0 to 9. So this one, as you can see, this looks simpler, and it just has 2 lines of codes compared to 4 lines of codes here. So for versus while. For, we often use for if we know the number of iterations, and if the iteration is unbounded or we don't know the limit, it's better to use while. So for uses a counter, and while can use a counter but must initialize before loop and increment it inside loop. This is what I explained earlier about the sentry. So you have a sentry, you initialize it, and you have to make sure that inside the loop or inside the while code block, the sentry is incremented or is changed. Then you can rewrite a for loop using a while loop. However, you may not be able to rewrite a while loop using a for loop. So we could say that while loop is more general than for. Okay, so but we cannot really decide that one is best over the other. Okay, that's why they have their strengths and their weaknesses. The important thing is we know when to use for, or when is it better to use for over while, and when is while better than for. So there is a very important command or statement in using loops or in working with loops, and it is a break statement. So a break statement immediately exits whatever loop it is in. So if the program encounters a break statement, it skips the remaining expressions in the code block and exits the loop immediately. Okay. Also, you have to keep in mind that it exits the innermost loop only. For example, here, if you have a loop within a loop, because this is a nested loop, so or nested while. So we have a while inside a while, and the break is inside the inner while. So if this is encountered, if the program encounters this break, control is passed to expression D, or rather expression C. Sorry. So if the program encounters break, control is transferred or control goes to expression C. Okay? So it is still inside this outer while loop. Therefore, after this, the while loop condition 1 will be executed. There are many, well, the break statement is somehow controversial because for some programmers, it's helpful, but there are other programmers who, as much as possible, avoid using break because they say that the break statement it's like confuses the flow of the program or the algorithm. So it really depends. I guess it depends on the style of the programmer. So here is an example of break statement. So we have for here, and here we can see for I in range 5, 11, 2, and if sum is equal to 5, break, print my sum. So what do you think is the output of this short program, these lines of codes? So the output is, because the initial value of I is 5, and then here my sum gets 0 plus 5. So my sum is 5. If my sum is equal to 5, this is true, it breaks. When this encounters break, this my sum plus 1 will not be executed. So this control goes right away to print. So the output here is 5. So in the are you okay problem, so I showed earlier the solution or the code for the problem, are you okay, here. And we can have another code for that, or a variation to that code, which is here. So we can loop while true. This means there won't be a way to exit here this loop by checking the condition here alone, because this will always be true. And then inside the loop, ands get input, are you okay? If ands is equal to yes, break. So if ands is equal to yes, break, then control goes here. So although this condition is also always true, there is a way to exit this loop. Okay, this will not be stuck in an infinite loop. If the user answers yes, it will exit. Okay, so this is an example of, example of the, this is a use of the break statement. While and flag. So some programmers do not like using break and do not like seeing Boolean value as conditions in while or even in if statements. So here in this example, we can use flag variable. For example, here I named it keep going. So the initial value of keep going is true. So while keep going, we ask the question, are you okay? If ans is equal to yes, we set keep going to false. So the next time it goes to the program goes to this condition, um, if keep going is already false, the program will print, wow, I'm happy for you. So I showed you, so at this point, the problem that I used to explain looping, so that's the are you okay problem. I showed you one, two, three solutions. So as you can see, a problem may have several solutions, and it's really up to you how you write your solution, how you write your code. The algorithm may be different. So the difference actually lies not just in coding, but in the design of the algorithm itself. Okay, so that's why I told you earlier that it's okay to get to look for syntax in Google, but then it's not okay to get the algorithm or solution online, because the solution is your product. It's a product of your brain, and what we really want is for your brain to think about a solution, or to develop the skill of solving problems. Okay, so um yeah, so it's really important to think about the algorithm or the solution. Also, this shows that one person, a programmer, may have a different style from another person. So as we go on, as your teacher, um, I or we can see your style. Okay, so sometimes we know if the code or the solution is from you or from someone else. That's why we really urge you to work on your problem or your exercises alone or by yourself, to avoid any problems later on. All right. So I mentioned uh, infinite loop earlier, and yes, infinite loop may be a problem in while and for constructs. This is actually a common problem. So, as I said, you have to be careful um, with your sentry, with a condition. Make sure that the sentry has initial value. Make sure that the sentry is being changed inside the loop code block, and um, or you have a way of exiting, such as by using break statement. So yeah, so well, if your program is stuck in an infinite loop, you just have to exit your program. So let's take a look at an example. Let's say we have this problem. Write a program that lets the user enter 10 integers and then outputs the highest and lowest integer. So the algorithm is here. So create an integer variable num, ask the user enter an integer and put it in num. Create an integer variable max and with an initial value of num. Create an integer variable min with an initial value of num. And repeat the following 9 times. So ask the user for an input integer, and then if num is less than min, assign value to num to min. If num is greater than max, assign value of num to max. And when this loop is done, show to the user the highest is max and the lowest is min. Let's go to our code. Again, I copied and pasted the algorithm here. And the next step is comment them out. Create an integer variable num. Ask the user integer, put an integer. So num gets input, enter, enter an integer. So we are working with integer, so we have to cast this because the return of input is string. Create an integer variable max and put num. So we have max here and the value is num. Put space. And then create an integer variable min and assign num. And then here, repeat the following 9 times. So we know the count or the number of times we have to repeat. So probably the best construct is to use is for I in range 10 colon, ask the user enter an integer and put in num. So it's just this part again. And then if num is less than min, assign value of num to min. Min gets num. Then next we have if num is greater than max, max is assigned the value num. Then that ends our for. And then show user, so it's print. What do we want to print? Highest is max and what's the other one? Lowest is min. Okay. All right. You will notice that max and min have different color. Okay. So this means that max and min have special meaning in Python. So it would be better if we change the name of these two variables. So instead of max, we can write largest. Instead of min, we can use smallest. So here we use num is less than smallest, oops, mean get, or this is equals, let's assign the values num, max is largest, max largest, and here we have largest and smallest. So save, do not forget to save, and then let's run our program. Input an integer, let's say I'll input 5, enter an integer 7, -8, 12, 54, 0, 34, 9, 1, 2, 3, 4. So highest is 54 and lowest is -8. Is it correct? Yeah, I guess so. Okay. By the way, we have 18. Okay. So this is an example of a problem that uses looping. And yeah, that's all for today, and have a nice day.